Okay, hello everyone. Now we will be doing what today? Data handling and statistics. That's the last part of paper 2. Now there are usually two questions. One is like this one, as you see, cumulative frequency ogive diagram, estimating mean, median, or box and whisker type of questions. And the other question is usually a regression line question. So we will go through all of them. I have those solutions, so I want to check these questions with the memorandum. So let's read the question and let's check the memorandum. How can we get those marks, or how can we get part marks? Now, first of all, you know the frequency, the intervals are given, and cumulative frequency, we add and write. We keep adding and writing those values. So it must add up to the total number. For example, if we have, like, we write 1, and then 1 plus 2 is 3, 3 plus 9 gives us 12, 12 plus 12, 24, plus 11, 35, plus 9, 44, and plus 6, 50. So it is fine. That's correct. Yeah, all the sum should be there. So that's completing the table. And drawing ogive, what was important here, let me just remind you, we must have an x-intercept at 0. So that point is important. So we must have 30 and 0 plotted. Okay, that's one coordinate. And other points are all the upper boundaries, like 40 and then 1. You see, it's going to be the next point we will plot is 40 and 1. And then it's going to be 50 and 3. So it is 50 and 3. So it will carry on like this until the last one will be 150. So the last coordinate we plot is 150. So then we will join them. But what is important is the point that we start, 30 and 0, and it is 40 and 1, and it is 50 and 30, 50 and 3, not 30. So that's 3. So these are that's 0, that's 1, and the last one is 50, 150. Okay. And estimate how many learners obtained 75% or less. As you see, 75% is not one of the boundaries, so it's in between 70 and 80. So from 75% on x-axis, we will estimate the value of cumulative frequency. So cumulative frequency will be our y-coordinate, and percentages will be the x-coordinate when we draw. Okay. Now let's have a look at the solution, how it is done. Okay, that one is fine. And if you just see how do you get part marks, is they give marks like you write first 2, 3, and then 12, and then the other 3. So somehow it is 3 marks, but usually it could be like, it could be only a 2-mark question anyway. And then in terms of drawing, let's see how do we get marks. So the upper limits are important. As you see, it starts from 0, 30 and 0. That's the point I told you. And it is 40 and 1, 50 and 3. So you plot those values, and when you plot them, we will just join them. We will just join to find the answers. So that's the thing. And for 75%, so 75% goes from where? You see, we need to actually estimate it. Let me take it in this way. 75 is exactly actually in the middle of 70 and 80. You see, that must be the point. And from that point, I go to right. You see that direction. So what do we see? From x coordinate, we go up. Let me write. Let me draw in red. So we go up and up and up. So then when you find the point, then you go left and left and left. So whatever that coordinate is your estimation. And as you see, any answer between 28 and 30 is accepted. So they give you a few values to get full mark. Okay, that was the first question. The second question, a few numbers are given. We need to find 5-number summary. What is 5-number summary? It is minimum, Q1, Q2, Q3, and the maximum values. So obviously the numbers must be arranged in an ascending order. That's one thing to be done. And then depending on those values, we will draw a box and whisker diagram. Just be careful, it must be scaled. Okay, let me write you be scaled because you are going to, you may be having comments on it. Actually, yes. The next question is asking us a comment. So if your scale is wrong, then your comment may may end up a wrong answer. Okay. Now finding the standard deviation, it's just calculator, answer full mark. So please learn how to use calculator there. And even use standard deviation to comment the spread of the data. Remember the meaning of standard deviation. Standard deviation gives us an idea about spread of data. So what can we say? If the standard deviation is larger, then the spread of the data will be wider. We can say that. So, or we can say the range will be bigger. Maximum, there will be difference, much more difference between maximum and minimum values, minimum and maximum values. So the spread will get wider if standard deviation is big. So that's what we will say. Now let's check the memorandum. Let's check the memorandum. What does it say? You can, oh, memorandum is in the next page. Yes. So as you see, all the numbers rearranged. That's fine. How many numbers we had, by the way? Because we just need to, I want to mention if there are even numbers or odd numbers that make a difference. So it is 1, 2, 3, 4, 5, 6. So it is 12, so 15 numbers. Now out of 15 numbers, you can imagine, so we have the first 7. So the 8th position will be the mean. So, so we have the first 7 numbers. 8th position will be, sorry, median, and there's another 7. Okay. And when you have 7, 7, you can divide it 3 and 3. So the 4th position will be Q1. So 8th position is Q2. And then what will be the Q3? It is after 8, you add another 3. And then you will end up 12th position. Okay. Remember, those parts are like there is 3 numbers. There are 3 numbers. And the 4th one, there's another 3 numbers. So it makes 7. And the 8th one, there's another 3 numbers, which is 11, and the 12th one, there's another 3 numbers. So 12 plus 3 is 15. So that's how we, so we can just find the positions 1, 2, 3. Third one, this is Q1. You see, sorry, the 4th one. 1, 2, 3, 4. This is my Q1. And then 5, 6, 7, 8. The 8th position. This is my Q2, as you see in the order. And the 12th one. So it is 8. 9, 10, 11, 12. So 12th number is 35.4. So that's how you find those values. Now, how do we draw this scatter plot? It has to be scaled, and to be able to draw a scaled diagram, we will better, I strongly suggest that, draw a number line just below, and that number line should be scaled. For example, we know we have values from 12. You can see the minimum value is 12.4 and the maximum is 40. So you can just arrange. So you can say that's my 10, okay, and my 20, and then my 30. Actually, this doesn't look scaled, by the way. I don't like this scaling. Okay, anyway, so then 10, 20, 30 should be somewhere here, and then 40. Yeah, this scaling is not good in this diagram. Okay, let's do it ourselves, since we didn't like this memorandum, this solution. Let's do it ourselves. Okay, I'll just draw it down there. We know the values anyway. Let's draw our own box and whisker. Okay, now we are drawing this. That's what you're gonna do. Sometimes that straight line is already given. Okay, so you'll just draw on the top of straight line. Yes.
But do we have to do the number line? Is it 1 mark for that?
To be able to have a scaled diagram, it is important that you see. Otherwise, your graph may not be quite scaled, or you may have a wrong comment actually. You see, the distances between 20, 30, 40 should be same. That's what I mean, number line. See, number line doesn't need to include like 10, 11, 12, or all the numbers. So you can just have 10 to 20, the same distance taken 20 to 30, another same distance taken 30 to 40, something like that. So I'm just using freehand drawing, but with a ruler, you can just make like every distance can 2 centimeter, whatever. That's enough. And then now we can draw the 5 numbers. And how does it work? 12.4 is the first one. So 12.4 should be somewhere here. So that's my 12.4. And then 19.7 should be just before 20. So that's my 19.7. And then we had, what was the median? 23.7. So 23.7 should be somewhere there. 23.7. You see, it must be before the midpoint of 20 and 30. And then what else? We have 34.5, almost in the middle of 30 and 40. And finally, that is what? That is 34.5. And finally, 40.01, just almost 40. So when you draw this, so it gives you a much clear idea. So we can draw our whisker, and then there will be box. Okay, sorry, let's just draw that box. Yes, and then there will be another whisker. Oop. Again. So that's my box, and that's my whisker. So that's how you draw. It is not very different than what they drew, but that's the idea. Now, in terms of having scaled or not, now what do we see? It's not bad, just that different. You see, this is a bit larger in the memorandum. That's why I didn't like it. You see, between 19 and 23, and 23 and 34, it must be at least twice as bigger. You know, that's better. Now, in terms of writing comment, you see, the whole thing is actually, or the median is closer to the lower values. You see, between median and the smallest value, minimum value, it is like 11. But between median and the maximum value, it is like 17. You see, that's larger, that's smaller. And what does it mean, by the way? Median is the mid number. Half of the numbers are less than that. Values are less than this, 23. Half of the values are more than that. That means most of the values are closer to the minimum value. Most of the data is closer to the minimum. That's why we say it is skewed to the right. It is positively skewed. Okay. You may say it looks like approaching through the left when you look, but it will be opposite thinking, remember. Okay, that's what we do. And then 2.4 was their question. 2.4. Oh yeah, 2.4 was what? Standard deviation and the comment. Okay, let's just check. So what is 2.4? You just find with calculator, you see answer only full marks, 2 marks. So that answer is definitely from calculator. You will get, please check and enter correct marks, correct values when you are using calculator. Because, for example, instead of 23.7, if you just write 237, you may get quite different answer. And you just lose 2 marks just like that. Just to make sure and be careful that what you are entering with and how you are entering those values. Okay. And what about the comment? A small standard deviation indicates that the data clustered around the mean. Yes. And a large standard deviation indicates that the data is more spread. That's actually the meaning, what we should understand from standard deviation. All right. So, and we had a few examples on this. What was it like? Remember, if you had 2 classes and they have different, they have the same mean but different standard deviation, or if you have 2 products, they have the same mean of life, but then different standard deviation. So what does it have? So that's let's just see standard deviation. For example, we have 2 classes, class A and then class B. So what does it tell us? Let's say class A and class B has the same average, both 55%, 55 and 55. But now standard deviation, let's have different values. Let's say class A has a smaller standard deviation, 4%, but then class B, let's say, has 12, as a larger standard deviation. Now, what we should think when you see this information? We have 2 classes, they have the same mean, the average mark for each class is 55. But then standard deviation, because class A has a smaller standard deviation, that means the spread of the data is not that much. Okay. So most of the learners, we can say, is around mean. So most of the learners in that class is getting marks around 55. But in class B, it's not like that. We may have learners who are getting 90s, 95s. On the other side, we may have learners getting 20, 25, or 30. So there's a wide spread of this data. Now, in such a case, if you were a teacher, you would prefer teaching class A, because most of the learners are in the same level, around the same level. The learners are getting around 50 and 60, you know, those marks. So if they understand something, everybody understands. And if someone didn't understand, so most of them didn't understand, you can teach again. However, in class B, it's not like that. There are learners who understand just like that. And there are other learners you can keep teaching and they don't understand. So that class will be difficult to teach now. Okay, and meanwhile, let me just mention. Okay, hello everyone. Now we will carry on this 1 or 2 standard deviation of the means idea. What is that? So if we are looking for 1 standard deviation, 1 ST of the mean from the mean, let's say, or when we have 2 standard deviation of the mean. So what are those intervals? Basically, for the 1 standard deviation of the mean, it's like standard deviation will be added and subtracted from mean. And in the second one, 2 standard deviation will be added and subtracted from the mean. Will be added mean and subtracted from the mean. So that gives us an interval. So what will be the answers like in the first and in the second examples that we had, class A and class B? So let's write down 55 minus 4, that's 51%, and then 55 plus 4 is 59%. And in the second one, 55 minus 12 is 43, and if you add, it is 67%. And if you add and subtract one more, 4, so the first one gives us what? It is 47, and then if you add one more 4, it is 63. And in the second one, if you add and subtract another 12, so that will be 31. And if you add another 12, so it is 79. So now, and it could be wider, but what we see in general, it is accepted that in a normally distributed data, 65% of the data of the marks lie in 1 standard deviation of the mean, and in 2 standard deviation it goes up to even 95% of the data. Now that's why we are telling, like the learners in class B might be getting 30% or 80%. So there are different levels of learners because it has a larger standard deviation, it has a wider spread of data, wider spread of marks. However, on the other side, class A, marks are around 47 to 63, almost all the marks. So it is a bit it's a bit easier to teach in that class since the learners are around same level. Okay, we can even say class A is more reliable because all of them are around same level, like 50%, 55%. And class B, you can have any surprise answers or any surprise learners. The top learners can be in class B, yes, but the lowest learners, slowest learners will be in class B as well. Okay. So now we end up these first 2 questions in this type. There's another question. Let's see how it goes with the memorandum and everything to get through the idea. This time in this question, we are given some temperatures, 10 consecutive days in March. And what's the mean temperature? You can just get the answer or with the calculator straight 2 marks. How many recorded temperatures lie outside 1 standard deviation from the mean? You see, that's why here we find the interval of 1 standard deviation, and then we check how many those temperatures not in that interval. Okay, that's what we do. Now use the scaled line. So draw box and whisker. You see, there's a scaled line, a number line is given. So that will help us to draw a scaled box and whisker. So then we need to, okay, that's the thing. And the next one, ask possible outlier, showing the calculations. And okay, outlier is a day which is too high than the others or too lower than the others. And if you just go through the temperatures, you see that 17, like, you see the second lowest after 17 is 25. So that is really an outlier. That's really a cold day, unexpected. All of those, days out of 27, 28 degrees, too many. So they all around there, but 17, that's an outlier, we can just see. And there's a formula for this that can be used. That is 1.5 interquartile range IQR is added to Q3 or subtracted from Q1 in that way. And then finally, possible explanation of temperature 17. We can write any reasonable condition, like any reasonable answer will be accepted. So if you go through the memo, as you see, writing mean straight is 2 marks using calculator, and then standard deviation must be done again with calculator, and just adding 3.41 to mean gives us 29.71, and if you subtract 3.41 from mean, you get 22.89. So that interval is the one standard deviation interval. So how many temperatures are below this and how many temperatures are above that? Actually, we only see 17 as below day and 30 degrees as an above day. So the answer is 2. Okay. And using the line, we can draw those mean Q1, Q2, Q3, Q1, Q2, Q3, and then we can have box and whisker diagram. That shouldn't be a problem. Oh yeah, this is what I was telling you. The Q, to find any possible outlier, actually 17 is the lowest. That's why from Q1, if you subtract 1.5 of IQR, the interquartile range is 3. 1.5 of 3 is 4.5. So when you subtract 4.5 from Q1, it gives 20. So any temperature below 20.5 in such a case will be an outlier. Okay. It was a cloudy day. There was a cold front. It was a rainy day. So any appropriate answer will get you that mark. Okay, we have this another question with the ogive and cumulative frequency. So it's just like the first question. I'm just checking, is there anything different? So we can skip that. This estimation, a number of learners taller than 155, that's we will be using ogive, okay. And estimate the mean. Remember, mean of a group data, we have to multiply frequency, which is the number of learners in each interval, times the values, and the values is what? X times F, remember in the formula? So it is frequency times midpoint of the intervals. So it is midpoint of these two or that two, and so it's midpoint of 120 and 130 is what? Add them divided by 2. So 250 divided by 225. This is 135, 145, so these are the midpoints, okay? So 125 times 21 plus 135 times 43 plus 145 times 6. So you'll keep adding as the last one, 175 times 9, and divide all of them by a number of learners, which is the sum. Okay, it is 300 learners. We can see it in the question. So that is a way, or again, you can use calculator. Just make sure your frequency is on in the calculator. So you can write the midpoints to the calculator and the frequencies, and the calculator gives the answer. Even the standard deviation of such a question, you can get straight from calculator. Okay, and what's the idea of using midpoint of intervals is actually this. We know 21 learners has heights between 120 centimeter to 130. Now, we don't know the individual heights of these 300 learners. You see, we have to estimate it. And that's why, as a best approximation, as a best estimate, we take the midpoint. Now, some learners could be 121 centimeters, some of them maybe 122, some others maybe 129. So there will be different numbers out of this 21 in that interval. I mean, we don't know, maybe they all 121 degrees or 129 degrees. But since we don't know, as a best estimate, we take the midpoint, okay? That's the idea. Now, if we check the memorandum of this question, cumulative frequency, you add and write, that is fine. Ogive diagram, we can just draw. Remember drawing ogive, let's just mention it one more time. It has to start on x-axis, like 120, as you see, that's here. And then you always write the upper boundaries, 130 and 21, that's a point, 140 and 63. That's another point, and it goes like that. The last one is 180 and 300. Okay, that should be the last one. So that's how we draw And yeah, estimated mean, exactly they haven't done with calculator, but you can get the answer when frequency is on, you can get the answer from calculator. Okay, now another question. Let's see, is anything different? The question asks mean, median, standard deviation, and how many complete within one standard deviation. So it's not a different question. We can just skip that. In this time, they just ask within. Okay, it's inside that interval. We will find the possible number of values which are in between that interval. Okay, the interval that we mentioned at the beginning. All right, so that should be fine. Now, another question, this time we are given a box and whisker and then ogive. So let's just see, is there anything different to be mentioned here? The ogive is given, read of the value of 60th percentile. So 60th percentile and the interval of frequency, the highest. Okay, so it is like whenever the graph increases the highest increase, as you see, as you notice, that will be the highest frequency, which will be the model class, by the way. And then drawing box and whisker that we have there, that's fine, as you see. And how the two sets of results compare. So, oh yeah, we have September test as a box and whisker, and then we have exam marks, so as an ogive. So they want us to compare. So you can see the lowest mark in September is 41, highest is 99, and it's almost same. You can see the lowest mark is like 40, 42, maybe 44, and then highest is here. You can see it is 98. So, and we can even find out the mean and quartiles here, like, because if you have how many learners, we have 27. You see in the question it says 27 learners. So the middle value of 27 is 13. So 14 from 14, you can just find out and get down. So that will tell us around 70 as a median. Yeah, so then we can say, look at the median in the September test. The median mark in September test is 59. So here it's almost 70. So that's why we can say the exam marks are much better than the trial. We can say that maybe, okay, because in the trial, half of the learners got less than 59, half are more than 59. But in the exam, if our estimate median is 70, half of the learners get more than 70. That's good. Okay, so that's how we make comments on that. Again, let's just go through with the memorandum just to make sure is anything different, or how do we get part marks in such case. In such cases, so 60th percentile is basically 60% of the people. 60% of how many people we have? 27. So 60% of 27 is gives us, that's how you calculate it, as you see, it's around 16. So 16 learners make almost 60% of the group. And what will be the 60% of 27? Okay, 16. So from 16, what do we get as the value to see as a mark? So we can see 74 because 16 is somewhere here. You see, from 16 you go left and get down. It is around 70, more than 70, 72 maybe. And as you see, yeah, a set of numbers are accepted. Any number from 72 to 75 is accepted. But we move from 16. And how do we get 16? Because it says 60th percentile of the data. So which is 60% of the data, we can say around 16. Okay. And then this is basically model class where you have the highest jump. Okay, 5 number summary. 5 number summary is same as from the graph we mentioned from ogive. We can find out from the middle 27 is half of 27 is like 13.5. So it's from somewhere here gets down. So it's basically estimation using ogive, you know that. And accordingly, we can even draw. Box and whisker. So since they draw in this way, and as you see, in terms of comments, just like we have done, see the median has increased from 59. The median in the original in the September paper was 59. Remember, it's 59, yes. And what we said the median in the final, we were even talking it was like around 70%, isn't so? Median increased And a few other comments you can make. Generally, all the marks are increasing that way. So half of the learners got more than 70%, so that's quite good. So we can say the learners perform better, overall performance is better in the final examination. That can be said. Okay, so there's another set of data. It's like all seems fine, but let's do it and see what can be done again. So we have a group of numbers, a set of numbers. How many numbers? 1, 2, 3, 4, 5, 6 numbers given. Oh, their mean is given. So what is the missing number? Okay, you know, since 6 numbers mean is given, we actually know the sum of these numbers are what? 6 times mean, 6 times 27.5. So then we can just find the missing value. Their sum will be that number. So another information given, the ages of people. Some famous people are here. So what's the mean of this woman? What's standard deviation? 5 numbers summary, interquartile range. Okay, all should be fine. You can go through this with the memorandum. Nothing seems different. All right. So the memorandum is there. Mean, standard deviation, the interval, interquartile. There is another similar type of question. Cumulative frequency, draw ogive, and estimate the quarters. Lower quartile is Q1, upper quartile is Q3. We can find IQR. That's another similar question. Okay, so that was, as you see, that's a good shown there. That's what, as you see, how we estimate the value. See, highest value is what? Whoop, 160. We have 160 people. So basically, we are dividing 160 into quarters. That means, as you see, we go 40, 40, 40, 40. So 40 gives us Q1, whatever it is. That's for Q1. 80 gives us Q2. And then 120 gives us Q3. Because 160 is split into 4 equal parts, because these are the quarters. That's how you find quartiles. All right. So average mean, interquartile, standard deviation, all the same. I want to get regression line questions. That's the last part left. We haven't done. Maybe next section, we can have a short period of regression line questions. As you see, we are getting there here. So for this session, let's close this period now and just start the regression questions, leave our regression line questions for the next section of standard data handling and statistics. Okay, hello everyone. So this is the, let's say, the last session of statistics and data handling. We had small parts done already. Now here I want to focus more on regression line questions, but let's have a look. This looks like a regression line question, but it may not be anyway. Let's see. There's exchange rate that's given per month, different months, and the oil prices, okay, in a year 2010. So draw scatter plot, we will just plot those values in oil prices. So it will be the exchange rate and the oil prices, we can say X and Y coordinates in that way. Usually the time related values are, we can put them on X-axis, okay? And most of the times it is given on the diagram sheet anyway, I'll tell you. If not given, the time related data information, the ages, the years is better to be done on X-axis. Basically, it is independent variables goes into X-axis, and the dependent variables, we can put them on Y-axis, because we can say oil prices depend on exchange rate. Maybe that's what we are looking for. Is there a relation? Anyway, so we'll check it from the memorandum, and it says what? Describe the relationship. So once it is drawn, it will be much easier to see what's happening. Like, is there any such relation? Is those dots on the scatter plot are just spread around, or is there an inclination of increasing or decreasing together? So we can only understand that after we had seen the dots on a scatter plot, okay, of the plots. And determine the mean oil price. It's just the mean for the second row, okay, that shouldn't be a problem. And even standard deviation, we can get the answers from calculator again. Remember, just type in the values in standard deviation mode, statistic mode, and then the calculator gives you the mean and standard deviation just like that. And then generally, there's a concern from public when the oil price is high or deviations mean. in which month would there have been concerns from the public? So you'll just check which month we have this higher oil price comes and the public can such a concern. That's what we will check again. Okay, now let's just check the memorandum. As you see, when it is plotted already, that is easier to realize. So there is actually such a trend. And as the trend written, as the exchange rate increases, the oil price decreases. So it's like going down. Okay, that's the trend. That's what we figure out. The mean and standard deviations from calculator, that wouldn't be a problem. And as an outlier, that was the question. So that first value seems to be too high, too away from the others. So the line goes like that, but now 6.8 and that 81 is quite above. So we can just mention that as an outlier. And what was 1.5? The concerns, that was 1.5. But they didn't ask outliers, they just said the concern. You see that value 66.8 and 81, that is the one actually which is kind of outlier, and that's what we said. The concern came here, and you can see easily that from the scatter plot. All right. Now, okay, that wasn't regression 9 question. Anyway, what about this? It's not definitely a regression 9, but it's something a little bit different. As you see, it's a strange box and whisker diagram. Let's have a look quick. The range of Peter's scores. Okay, that's range is maximum minus minimum. So maximum is 94, and minimum is 68. So you can just find their difference. The minimum of Vianney's score. See, Vianney has no that whisker. No, that's so that means, what does it mean? The minimum mark and Q1 is same. And then there's median, Q2, and there's Q3, and there's maximum. So it is possible we can have such different strange box and whisker diagrams. Like imagine if we had Q3 same as maximum mark, so there wouldn't be the other whisker as well. We will just have a box then. Or if we had, which is possible as well, if we had like Q2 and Q3 are equal, like we had too many marks like same in around the middle value. So then that can make Q1 and Q3 equal, or that can make Q1 and Q2 equal. So then we wouldn't have that middle line. So we may have such different box and whisker diagrams. Okay, that's why I just want you to see this graph and don't worry about what's happening. And then it says comment who had more consistent. As a consistency, we can just say the spread of data of Vianney is much closer. So he seems to be, even though they have the same average 80, but the Vianney's marks are all around 80. You see lowest is 76, so highest is, so that's more consistent. Obviously, Peter has a better score like 94, but then he got 68 as well. So it just tells us Peter is not that consistent learner. No, he can just get a good mark or just a low mark. Okay, now there we go. Now there is a regression 9 question. You may get such question information given in the table, and even the scatter plot is given. Okay, so you can see what's our X values, by the way, number of days training. You see, this is about time. There's another thing with time taken in seconds. So you see, your time taken in seconds depends on number of days you train. Like generally we expect what? We expect if you train longer, if you train more days, the time taken should take shorter because you are more trained, more experienced, and you can finish whatever you are doing, or this athlete is running, or whatever you do, you will have more experience and you can finish earlier. So that's a trend. Okay, that's fine. We can say, actually it says discuss the trend. Okay, that's what we should say. Don't say just the negative gradient or negative trend. Okay, try to describe, try to write, so that makes you understood what the question is. So what the question is telling about. So what you can say, for example, as the number of days training increase, the time taken in seconds will decrease. You know, that will be much more understandable as a discussion or as a description for the trend. And identifying an outlier. So we know whatever dot is above or away from the others, let's say that way, because it can be below somewhere here, or it can be above somewhere there. And as you see, this dot here will be the answer. And you say 60 and 18. Which day it is? 60 and 18. Yeah, this is the one. 60 and 18.1. So that's an outlier. All right. So that person or that guy who trained 60 days, you expect him to make it shorter, quicker, because he trained that much. However, something might be different with him, whatever the reason is. So that outlier can have different excuses, whatever it is. Now, 1.3 is our question, regression 9. That's from calculator. Regression 9 equation is given in the formula sheet as y is equal to a plus bx. So using calculator, we will get the values of a and then value of b, values of a and b, and then we'll write the answer. So just be careful plotting incorrectly in calculator and getting those values correctly. Now, most of the time, like in this question, we will be using this regression line to make an estimate or prediction, an estimation or a prediction. For example, if someone tells us, according to this data and with your regression line, an athlete comes and he says, I trained 75 days. Okay, so what do you expect him to finish his race in how many seconds? So according to those people's given data, someone who trained 75 days, so we substitute x with 75, and that equation will give us a y value. Because remember, we have a, we have b, we have a straight line equation, we have a regression line equation. It's like best fit line equation, okay? So then that will give us a prediction. Obviously, that guy can be an outlier. So he may just surprise us, but we can expect, we can predict, he can finish this much in this much of seconds, this race. Or other way around, for example, you may have a question, someone finished the race in 12 seconds. So how many days you expect him, he must have trained? You know, someone says, okay, I finished this in 12 seconds. So you can tell him, according to my predictions, you must have trained, for example, 70 days, or you must have trained 85 days. You know, using substituting y with 12, then you find value of x. Remember, y is the seconds, so it's 12 seconds, and then x gives you a number of days you trained. Or x is the number of days you trained, let's say 75 days, so then that gives you an expectation of your time taken, okay? Now, correlation coefficient, which is R, again, those A, B, and R values are calculated from, determined from calculator. And how can we comment on this R? So remember, R values are between -1 and 1. So if it is closer to 1 or -1, that's stronger. If it is closer to 0, that's weaker. Now, what does it mean stronger and weaker? The stronger standard deviation, then we can say that regression line is more reliable. The reliable of our answers are, remember, we made a prediction, 1.4. We made an estimation. So that estimation is how reliable, how true can that be, depends on the correlation coefficients. Now, because this thing has a negative trend, our R will be negative. But I can say it's kind of a good relation between them. There is a good correlation. I can say it will be a strong negative. But let's check the answers and see what the memorandum says. Okay, as you see, the solution is not that long, the memorandum. So as the number of days trained increase, the time taken around decrease. Okay, that's what we said, no problem. The outlier we just mentioned and plot the point. Regression line, you find the values of A and B from calculator. Then you round off 2 decimal places and write the answer. That's quite nice. And as you see, what was 1.4? Let's have a look again. Someone trained 45 days. Yeah, that's right. You substitute x with 45 in the equation. So when you substitute x with 45, that gives 14 seconds. So if someone says, I trained 45 days. So you can say, according to my calculations, you must have finished this race now in almost 15 seconds, 14.67 seconds. That's what you say. And correlation coefficient, which is R, you get what? So this A value, B value, and the R values are from calculator. So you got that. And because it is closer to -1, we can say strong, but it says moderately strong, okay? that means we can say your estimation, your prediction in 1.4 is moderately reliable. Okay. Yeah, there's this another question. It says, what does it say? There's English and Afrikaans marks. All right. Now, in terms of 2 marks compared, which one will be on x-axis, which one will be on y-axis? It all depends on your answer book. Okay, you don't need to worry about that. And because they both match, there's no like something depend on the others, whatever you should think about it. So one of them will be x values and the other will be y values. So we are looking for a correlation between them. And again, when you plot these things into the table, then with the calculator, you can get AB values and the regression line, least squares regression line, and you can get R correlation coefficient. You see that just from calculator, 5 marks. And then describe the correlation. So depending on your answer in 1.3, depending on the value of correlation coefficient, you can say it is strong, reliable, whatever, or weak or moderate, strong. And then, yeah, you see, that's another prediction question. What does it say? Predict the final English language mark for a learner who got 74 in Afrikaans. You see, we know someone got 74 in Afrikaans. So according to this, if it is this group, using this group of data, what can his mark or her mark be in English then? Or it could be asked other way around. If someone get like 80% in English, so what do you expect him to get in Afrikaans? So that helps us, regression line equation helps us to make this prediction. Okay. So as you see, first of all, we just dot the points, the marks. So English language marks is on x-axis. They gave us, so we put them here. Afrikaans marks are over there. And the trend is what I can just say, they didn't ask, but what we can say, as the English marks increase, the Afrikaans marks increase as well. So we can say that that's fine. So we got the I and B values. So we got the equation, we got the regression line, which is correlation coefficient, 0.88. And we got, we can say, strong positive correlation. That's good. And finally, if someone got, what was it? 75, was it 70? Yeah, 74 in Afrikaans. So Afrikaans values are Y values. So in the equation, you substitute Y with 74. So 74 is equal to 18.04 plus 0.77x. So was it Afrikaans or English? Sorry, let me, my bad. Who obtained, yeah, 74 in Afrikaans. So we know the Afrikaans mark. So that's 74. So we will write this equation, and then whatever answer for X is our English mark. So that's the prediction of this guy who got 74 in Afrikaans. His English marks will be determined like that. And as I said, it can be other way around. They can tell us someone got 40% in English. So put 40 here and estimate his or her Afrikaans mark. And your estimation, we can say, is quite reliable because we have a strong positive correlation. All right, and let me mention, if the question asks draw scatter regression line, see they draw it here. Now you should make like touching on y-axis or x-axis, so that's easier to find. Remember, it's like actually drawing a straight line. So how do you draw a straight line equation? You substitute x with 0, so you get 18. So somewhere 18 that you start, and you can just have any other point. Okay, just have any other point on the diagram. So you can substitute, for example, 100. So someone who got 100 in English, what he might get in Afrikaans. So 100 and something, you will get that answer. So between 18 and 100, you can draw that straight line. Okay, so it's just drawing a straight line. And finally, one more thing, let me say, this regression line must be passing through the median of English and Afrikaans marks. Okay, so let me just write it here. So must be, so when you are drawing, it must be passing through which point? It must be passing through the median of X values and the median of Y values. And the question may ask that, or when the question asks you to draw more than 2 marks, you need to show, you need to show that's around 18, and the mean value, wherever it is, I'm just guessing, maybe mean is somewhere here. So that value, the mean of X and Y, must be shown that it's on that line. Okay. Otherwise, any other 2 point you can find, or any other point beside y-intercept, you can find and draw with a ruler as a straight line. It's basically just drawing a straight line question. Okay, what was the question 2 here? Question 2, they gave a set of numbers, that's fine. And the mean and the variance. By the way, what is variance? Variance, you get standard deviation with the calculator. The square of that value is a variance. Okay, square of standard deviation is the variance. Okay, and 2.2 seems a bit different. There is those sigma notation issue here, then sigma notation of those other values. Now, let's just understand, since it is a bit different, not regression line, but we can have a look. So what does this information tell us? We have starting from 1 till 22. So we have 22 marks here. They added up, okay? So remember, it means x1 plus x2 plus x3. So till 21. So instead of writing x1 plus x2 plus x3 plus xn, sorry, x22, we can write it in sigma notation that way. So the sum of all these 22 values is 1220. Now, how many boys in squad B? That's why we say how many numbers added. So that's the first learner, second learner, and there will be 22 learners. So you just answer will be 22, just like that, okay? And then the mean weight is going to be calculated. We know the sum. So we are going to divide 1320 by 22. So that will give me the answer, that's it. Because we know the sum of their what's it, their heights, their weights, yeah, their weights. Okay, and then the last one, standard deviation. Okay, now the standard deviation formula is given as, let me write what is given for mean. Like what is given for mean is actually that sigma notation, f times x over n. And what is given for standard deviation square, which is variance, is the sum of x values minus the mean squares and divided by n. So what we are given here is actually same as what is there. So we know that answer is 1012. So I can actually say it is 1012 over what? What was n? That's the first question, remember? So we have 1012 divided by 22 is square of standard deviation. So then my answer is just like what? Root of that thing. So root of 1012 over 22 is my answer. I can smile again. Okay. So just understanding those sigma notations and what they mean. Yes.
So please explain how you got that S squared formula again, sir.
Okay, that's given in the formula sheet. So the mean formula and standard deviation formula is given. But this part of standard deviation formula given in the formula sheet is actually what they gave us. You see, what they gave us is actually the numerator of this expression in the square of standard deviation. This is, by the way, variance, okay? So that's variance. Variance is given. Variance formula is given, let's say that way. So when we root it, so this answer is variance. What is variance? 1012, this value, divided by n, which is 22. So that's variance. So when we root it, yes, we got standard deviation, okay? And then last one says,
yes,
if 5 boys are equal weight are added to the squad of school A, so that the means of both schools are the same, what must be the weight of each boy? Okay, so the means of both schools are same. So we know the mean, so I don't have the answers now, but we must have that answer in 2.2.2, the mean of school B, and then we already got the mean of school A in 2.1, so that we can just find the difference and add 5 learners in that squad. So because we want the sum of, not the sum, we want the average same, isn't it? So that the means of both schools are the same. So the aim is to make their means same. Okay, so since I don't have those numbers, I can just write the answer, but we can go through here with the memorandum. See what does it say? So what do you see? first one, okay, that's from calculator. The mean of the first group is 57.74. And then the square of standard deviation, which is variance, is that's not a problem. 22 learners. Okay, the second group has the mean 60. Now, what we will do, how many learners in the first group? 20. Okay, remember we had 20 learners, you see. So that 20 learners will become 25 because we will be adding 5 people. And all same, you see, those, what are we adding? The sum is already 1,155. And we are adding 5 new people, all has the same weight. So x, 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 you see, that is the new sum. So that's why the new mean is going to be, this sum will be divided by 25, not 20 anymore. So that's what they did here. And that is going to be the mean of the second group. So that is going to be 60. And as you see, that is done here, that equation is written already there. So you can see 1,155 plus 5x divided by 25 is 60. So that's our equation, okay? And then you solve for x, that's it. All right. Another question looks like regression line. Yes, we have the heights and the arm span. So the arm span in centimeter is y-axis, then the heights are on x-axis. You represent, okay, you're gonna plot the values, you're gonna find regression line with calculator, and you will estimate, okay, using regression line, whoever has a height of 176 centimeter, you can find his arm span. That's just using the straight line you got in the previous answer, 1.2, and then the correlation is given. Comment on the strength of the data. Okay, it's just, you can say it's reliable, 0.8 match. So that question is all straightforward question that we have. You see the solutions. Yeah, I think we are almost done. Have we done any such question? So this is a histogram, and they may ask us, you know, they can give us an ogive and fill in the cumulative frequency and then frequency and then draw histogram. And there's that connection. Now the similar connection, it is written here. So using histogram, I can actually find the frequency, and with frequency, I can complete the cumulative frequency table. And with cumulative frequency table, what we draw ogive. So the same process can be done backward. They can give us ogive, so you can fill in, I mean, but in the ogive, it must be clear, you know, visible, the points, the dots, so you shouldn't be guessing. You can say, these are my intervals. So it goes 20 by 20 or 10 by 10. So you can fill in the upper boundaries, and so you can find the intervals. So you can fill in cumulative frequency. So from cumulative frequency, you can actually draw, you can actually complete the frequency table. It's just backward, remember, just like how you find from frequency to cumulative frequency. Now it's backward. You add an, in frequency, what we do, let's just remember, in frequency, first one you write as it is, and then add and write, add and write, add and write, add and write, add and write. In the second one, how it goes, the first one you write as it is, and the second one, this time you subtract and write, subtract and write, subtract and write. So it's backward process. And finally, from frequency, they may ask you draw histogram. Okay, so all this process can be asked backward. Otherwise, nothing is different here. You can just draw histogram, ogive, cumulative frequency. You can find intervals, upper quartiles. Okay, that's not something tricky. And all is done there. Scatter plot is given. This is age and the time. Yeah. So is anything special here? Anything special? Let's say this is our, we can take this as our last question. Let me just check anything different in this question we should mention. Hospital carry out patients. So there is ages on x-axis, the time in the y-axis. Okay, it's plotted. Draw line best fit diagram 1. Patient reaction time is an outlier. Okay, as you see, this almost all the other dots are like on a line like that. This point looks outlier. Explain why is C outlier or something. Any reasonable explanations should be fine here. Calculate the regression line. Okay, that's just with calculator again. Correlation, that is R, again, just from calculator. And 1.5 is, what is that? It's a bit different. Let's look at 1.234 first. It's so you draw the line, all is fine. Regression line, okay. Best fit line, you draw the equation, and it is very strong because R is 0.95. Okay. Okay, that's fine. As you see, 1, 2, 2. Any other reasonable explanation is accepted in terms of the outlier or the condition. Okay, reaction time is far away than the others or whatever. Okay, and let's just read 1.5. What does it say? First, understand the question. Hospital records this reaction test is taken in the following information. What does it say? Thousands, hundreds of a second, lower quartile, median, upper quartile for 15-year-olds, and 30-year-olds. Hey, it's a quite different values. So comment on the reaction time on the different age groups on this test. Okay. Obviously, the reaction time gets longer in terms of second when you get older. What else can you say? Okay. The 30-year-olds have higher reaction time. We can obviously see that. You can see those are 60, 70, they are 20. And what else can we say? Half of the reaction time here in this 15-year-olds are less than 22. Half is more than that. Here we can say half is less than or more than. Can we talk about the range? No. Can we talk about interquartile range? Okay, yes. The difference is what? The difference is 5 here. And in that interquartile range, it is 15. Okay, even interquartile range gets bigger in the second group. You know, just anything in that regard should be correct, as long as you have correct reasoning or reasonable explanations. All right, our last question. We need to draw on scatter plot. So as you see, the X and Y coordinates are given already on the table, so don't worry about. Sometimes it is given on the diagram, like here. Time taken is here, number of errors on x-axis, on y-axis number of errors, x-axis. So sometimes it is given here, or sometimes it is given on the table. So they will tell us like time taken, so that's our x and that's our y values. Anyway, the first one is just plotting them. The influence more taken, so it's kind of describing the trend and what's happening in this table. What does it tell us? Anyway, regression line again with calculator, coefficient. All right, all seems to be fine then. So that's all for we can say for regression line, and